come to De Moivre's theorem. So this mathematician, De Moivre, he invented the formula for power of complex number and also the roots of complex number. So let's see the power for complex number. If you have z equal to r cos theta plus I sin theta. So if you want to take a power n, so for r outside here, you just take the power of n. So this just follows, okay? So in the bracket, just write the structure cos plus I sin. And then let's look at our angle. For our angle, we need to multiply n. Okay, so this is the formula. Make sure that your n must be more or equal to 1 because you cannot have negative power. If you have negative power, this will become 1 over z to the power of n. So that is not the formula that we want to apply here. So n should be more or equal to 1. Now let's see the formula for roots of complex number. So for roots of complex number, meaning that you want to take the root of n. So for r outside here, as usual, it just follows. Just take the root of n and open the bracket, write the structure cos plus I sin. Okay, and then let's look at the angle. What happened to your angle is you need to divide by n. Okay, so since you have divided the angle by n, we need to realize that the argument that you give later on, it should be in one cycle. So since you have divided the angle here, you need to do also plus 2 pi k in the numerator. Why? Because later on, when your argument is small, you can repeat the step, you can repeat the answer until you achieve one cycle. So just add plus 2 pi k here, and then your k, we have the formula for this. The Moivres here have identified for you that your k should be start from 0, 1, 2, and so on, and you should stop at n minus 1. So when you stop at n minus 1, meaning that the answer that you give is exactly the argument is in one cycle from 0 until 2 pi. For example, if you take a cubic root, meaning that your n now is equal to 3. So later on, when you want to find the final answer, your k should be equal to 0, 1, and 2. Stop here because you should stop at the point n minus 1. So n minus 1 is just equal to 2. Now let's see how to apply the formula. Use the De Moivre's theorem to find a power. So this is your z. Okay, name it as your z. And then you want to take the 7th power. So this is z to the power of 7. So for your r, just follow, take power of 7. And then open up the bracket, write the structure, cos plus I sin. And then for your argument, let's just multiply 7. So now this is 210 degrees, so just write it here. So this is your final answer if the question asks you to give the answer in polar form. However, here they ask you to give the answer in terms of a plus bi. So just use a calculator here. This is minus 3 over 2. This is negative half. So just multiply 1 to 8 inside. So this is the final answer since the question asks you for standard form a plus bi. So you can see here that if the question asks you for polar form, we don't have any problem with this argument here because this is in one cycle. Now let's see example 15. Find the 6th power of Z3 plus I. So let's name this as Z. Z is equal to Z3 plus I. So now you need to take power of 6. So first of all, you cannot do straight away De Moivre's theorem because this is not in polar form. We need to change to polar form first. So let's find our r using Pythagorean theorem. So this is just equal to 2. And then let's plot the graph. So your A is Z3, your B is equal to 1. This is the point Z, Z3, 1. Okay, so you are in the first quadrant. So your reference angle here is just equal to your true angle. Okay, so shift tangent modulus 1 over Z3. So this is pi over 6. So now let's fill in our polar form. Z is equal to r cos theta plus I sin theta. We fill in our r is 2 and our theta is pi over 6. Since we are already in our polar form, now let's take power of 6. Okay, so z power of 6 is just 2 to the power of 6. And then write the structure in bracket cos plus I sin. And then let's multiply our angle with 6. And then let's solve this. This is just pi. So if the question asks you to give in polar form, this is your answer in polar form. However, the question asks us to give our answer in standard form, a plus bi. So let's open up. Cos theta is -1. Sin theta is 0. And then just multiply 64 inside. So this is your final answer, -64.